Hello. In this section, I will present a complete list of operators as well as kind of data object and a standard VHDL package. And also, I will give you some example. Operators in VHDL are grouped into 7 different types: logical, relational, shift, adding, sign, multiplying, and others. You can see a list of operators from lowest to highest precedence. First column shows the kind of operator. For example, in logical operator, there are AND, OR, NAND, NOR, XOR, XNOR, gate operators. Relational operators are including equal, not equal, lower than, lower and equal, greater and greater, and equal, and also in shift category, SLL means shift left logical, SRL shift right logical, SLA shift left arithmetic, SRA shift arithmetic in right, ROL rotate left, and ROR rotate right. In adding category, we have plus, minus, and also concatenating. Concatenating does by integrating the some bits together, and it does by ampersand. And also in the other operators, there are such as 2 star means power, and another ABS or absolute value, and not. In this slide, you can see the explanation of the VHDL operators that I explained in the previous slide. This table shows some example of shift operators. For example, the result signal is assigned by 2 shift left logical of the sequence of bits. It is done by entering 2 zeros bits from right and removing 2 bits from left and other bits shift to their left. Notice if you want to assign some bits in the identifiers like signal or variable, you have to write them between two quotations. But if you want to write just one bit, it is done by writing between one quotation. Another shift operator example is ROL, or rotate left. It is done by entering 2 first bits of a number from right and shifting the other bits to the left. And the table shows the relational operator, like the first one is it is means is a equivalent to B, or the second one is a not equivalent to B, or another is a less than B, is a less than or equal to B, or is a greater than B, is a greater than or equal to B. The concatenation operator or ampersand is often a useful operator when dealing with digital circuits. For example, first of all, we have to define all signals or variables. Firstly, then we want to assign something on them. Next slide, I will tell you how we can define signals or variable. Each signal has 3 parts: the name, type data, and length and initial value. In this example, C underscore val is assigned by concatenating 2 bits from right to right of A val. or cval is assigned by concatenating two ones from the left of bval, or concatenating one bit from left and one zero bit from the right. We can calculate the d value signal. Standard data types of VHDL include bit or acid logic. Acid logic uses for defining just one bit, 0 or 1. Bit vector or STD logic vector, Boolean vector, integer, natural, positive, integer vector, character, string, or signed or unsigned value. There are four types of data objects in VHDL: signals, variable, constants, and file. In this course, we won't discuss about file types. To declare the signals, first you have to write signal. After that, the name of signal. In here, the name is sig underscore name. After that, colon. After colon, declare the types of signal according to previous slide. And finally, by using the colon and equal symbol together to determine the initial value. I specified in the slide by yellow highlight. Variables and constant are declared the same as the signal, with difference that instead of the signal you have to use the variable or the constant. The second table shows different data object example. For example, in the variable category, write variable, then write the name of a variable. The name of variables in this example are variable my var1 and my var2. You can declare both variables separately or together. The type of these variables are STD logic or bit. Then by use this symbol as I highlighted, you can determine the initial value. Initial value is the 1 bit because you declare these variables as a STD logic between because there are logic, so you have to write the initial value between one column. In this slide, I want to discuss about the difference between variables and signals. Signal is assigned by this symbol. The symbol is less and equal symbol, but in the variable it is different, and variable is assigned by colon together to equal. A signal represent a wire or some type of physical connection in a design. If you use the signal inside of the process, the assignment is not immediately, but it is done after 1 clock. Variable assignment within process is different. The signal when a variable is assigned in the process, the assignment is done immediately. And another, we can't use the variable the outside of the process. And the main VHDL language library package that you will probably need to use in your work, as shown in the figure. They are including the STD logic 1164 or numeric STD, numeric sign or numeric unsigned, numeric bit, and mass real or mass complex. The package STD Logic 1164 in your code will give you the ability to use the several data types like STD Logic and STD Logic Vector. The library numeric STD uses for signed and unsigned data. The mass real VHDL provides you some constants of data like mass P. In this course, we use the package STD Logic 1164 and numeric STD for our project. Signed and unsigned data types are available in the IEEE numeric STD package. A signed value ranges from negative 2 power n minus 1 to 2 power n minus 1 minus 1. And unsigned value ranges from 0 to 2 power n minus 1, where n is the number of bits. This figure shows the example for declaration the signals and variable, and also use the best library you can work with them. Okay. Before using the signal or variable, you have to define the signal. After that, the name of signal, and after that, the type of signal. If the signal is a vector, so you have to define the length of vector by using the number of bits minus 1 down to 0. Another important notice, the Boolean variable or data type has two different values, false or true. In this example, you can see if you use the STD logic vector. So the best library is IEEE STD logic 1164, and if you use the unsigned and signed data type, so the best library is IEEE.numericstd.r. This example shows the different parts of VHDL code, the first define the library, after that entity, architecture, and process, and also define the signals or variable inside of the process. Package material includes these mass constant like mass E uses for Neper number, or constant mass underscore P uses for P number, and so on. This slide is continuation of the previous slide. Thank you for following my lecture. Please like this video to support and encourage me.